All right, we are in section 4.7 where we're going to use isosceles and equilateral triangles. We talked about the classifications of triangles earlier in chapter 4, and these classifications could be brought up into two categories. Those two categories are triangles classified by angles and triangles classified by their side lengths. Isosceles and equilateral triangles are ways that we can classify triangles by their side lengths. But from their side lengths of these two specific triangles, we have some characteristics that we can use to help us find angle measure. So if we look at this triangle here that's diagrammed for us, this is a triangle that's an example of an isosceles triangle because by definition, an isosceles triangle is a triangle with at least two congruent sides. So the little tick marks there represent the equal sides. And then we have what is called the base. The base is the non-congruent side in this particular example. From the base, we have two angles that are next to the base, and they go along the two congruent legs. Those, by definition, those are what are called the base angles. And then the other angle that's not part of the base angles is called the vertex angle. Now, the base angle has a great characteristic, especially in an isosceles triangle, is that the base angles are both congruent, which then brings us to our first theorem for today, and it's what is called the base angle theorem. The base angle theorem states that if two sides of a triangle are congruent, then the base angles are congruent. So if we can say that AB is congruent to AC, then by definition of the base angles theorem, angle B is congruent to angle C. Now, we're looking at the base angle theorem, but we also have what is called the converse of the base angles theorem. The converse of the base angles theorem is this. It's kind of flipping this definition here in order to find a similar portion of our triangle, which basically means this. Say we have a triangle here and say it's X, Y, and Z. And it tells us that these two angles are congruent. So the converse of this means that if angle X is congruent to angle Z, then that means that these two sides happen to be congruent. Then XY is congruent to YZ. Okay? So if I looked at these two triangles here, the one on our left, they want us to identify the congruent sides. What they give us is two congruent angles, angle M and angle O. By the definition of the converse base angle theorem, I know, since these are congruent, I know that these two sides have to be congruent. So MN would be congruent to ON. And if we looked at the triangle on our right, they give us two congruent sides, and because of the base angle theorem, I know that angle K would be congruent to angle L here and here. Okay? Now, what about equilateral triangles? Equilateral triangles, by definition, by the characteristics of their sides, means that all sides are the same. Just like this. And because they're equilateral and because it's a triangle, all angles are the same. So Not only are all the sides are the same, all the angles are the same, or all the sides and angles are congruent. And they have a specific degree for the equilateral triangle. Well, because we know that the interior of a triangle is 180 degrees, and let's say that this is x, and this is x, so 3x would be the value of the interior angles, so dividing everything by 3, x is going to equal 60. So it doesn't matter about the side lengths of an equilateral triangle. They could be 5 inches, they could be 25 feet, they could be 8 miles long. As long as you know that they're equilateral triangles, they're always going to be 60 degrees. Okay? So with this being said, let's try to find values for x. So this first triangle here, they have side lengths of 2x plus 10, 40, and 15. I know that these two angles are congruent, so because of the converse of the base angle theorem, I know that these two angles, or these two sides, I'm sorry, are also congruent. So since they're congruent, in order to solve for x, I can say 2x plus 10 can be set equal to 40 because they'd be the same. Subtract both sides by 10, I get 2x equals 30. Dividing everything by 2, x is going to equal 15. Okay, looking at the triangle on our right, I've identified that all of these sides are the same, and all the side, or all the measurement of the angles, I'm sorry, are 60 degrees. Since they're all 60 degrees, that means that this is a equilateral triangle. So that means the distance from here to here is going to be the same the distance from here to here. So x is going to equal 12. And then finally on this page I have a triangle with two congruent sides, which means by the base angle theorem, I know that these two angles are congruent. So all I'd have to say is x plus 7 and set it equal to 55. Subtract 7 from both sides. That means x would have to equal 48. Okay? In this example, they want us to find the values of x and y. So I look over here, and the one thing they do tell us is that AC is 36. So AC right here is 36. And I look at this triangle ABC, and I identify that all of the angles are the same, so that means that this is an equilateral triangle. Okay? And then if I look at triangle BCD, that is a isosceles triangle because of these two angle measures. And because of the angle measures, I know that the adjacent side lengths will be congruent as well. So since this is the same as this, and I know that that is 36, that means x is going to be a value of 36 also. Looking at this value here of y, again, because it's an equilateral triangle, all I have to say is 3y minus 9 will be set equal to 36 because I know that's the value from AC and it is an equilateral triangle. So I add 9 to both sides. I get 3y equals 45, dividing everything by 3, and y is going to equal 15. So I got x is 15, I got y is 15, x is 36, and the last thing here they says find angle ABC. Angle ABC is going to be 60 degrees because it's an equilateral triangle. Finally, they want us to find the perimeter of these two triangles. Perimeter by definition is the sum of all the side lengths, so the general equation for the perimeter of a triangle is A plus B plus C. Whatever the side lengths are, we just add them up. Well, what we need to do first for this one is find what x is. Well, because of the converse of the base angles theorem, I know that these two sides are going to be congruent. So I can set them equal to one another and solve for x. So I'm going to subtract x from both sides. I get 2x minus 16 equals 4. add 16 to both sides, and I get 2x equals 20, dividing everything by 2, x equals 10. But that's not what they're asking for. They're not asking for the value for x. They wanted the perimeter. So I have to plug in 10 in for x, and I get 14 over here, and I should get 14 over here as well. 30 minus 16 is in fact 14. So to find the perimeter of this, I take 14 plus 6, which then gives me 34, and it was labeled feet. Finally, on the one on the right, it tells us that all the angles are congruent, so that makes them an equilateral triangle. And I can use any one of these values to help me out, so I'm just going to set them equal to one another. I could have used these two, I could use these two, I could use these two as a combination in order to do it. So I'm just going to take the 2x minus 3 and set it equal to the x plus 5. So from here, I can add 3 to both sides, which gives me 2x equals x plus 8. Subtract x from both sides, I get x equals 8. So x equals 8. Again, that's not what they're asking. They're asking what the side lengths are for us to find the perimeter. So I can say 8 plus 5 equals 13. Then I'm just going to double check here. So I got 16 minus 3. That also equals 13. So that just means I'm going to take 13 plus 13 plus 13. And that gives me a value of 39. And since they didn't write down the unit measure, I'm just going to write down units. Okay? And that is being able to use isosceles and equilateral triangles. Hope this helps. Until next time.